Greetings, and welcome to our fireside discussion that we're about to hold here with Ippolito Caradonna, who comes to us from OgLab.
Thank you. Thanks for having me.
We welcome you, Ippolito. What a fantastic series of discussions that we've had thus far, especially coming on the heels of powerful discussions when we look at immersive technology, also with the revolution and the evolution of education. Yeah. Let us be ones that will help carry the torch forward and certainly not move back on this discussion. Ippolito, with the short minutes that we have, let's chop wood. I think about this world of spatial computing, mixed reality technology, the metaverse, immersive, interactive ecosystems of interaction and communication, if you will. But now we must take even more of a clear focus on science. And what does this relationship look like when it's AI powered, if you will, and thinking about AI as applied sciences in these large language foundational models that have deployed around the world, and they're becoming quite capable. When you think about this narrative, this dance, if you will, of AI, spatial computing, and science, what is the critical importance of this?
Ooh, this is great. And there's so many points to touch, but off the heels of a wonderful conversation, think about this angle. How do we train our scientists? How do we actually build up the scientist, the laboratory user, the inventor, or the people on the ground, right? As I call it, the frontline workers that are actually building the next group of historic vaccines, or building breakthrough drugs for cancer treatment and for other ailments. There isn't anything more humane than what's happening at that forefront. And in the intersection, we have to think about, again, how are we training up the scientists to solve the problems and to ask the right questions, right? And so I think now in the intersection and on the heels of everything that's been talked about in terms of immersive technology and artificial intelligence, it now is not a matter of how much data we can get, right? Because we have just volumes and volumes, and the data sets are so huge. It's not as much of the quantity, but it's the quality of the data that we can actually access with AI. And so I would say simply, are we asking the right questions? And in that regard, how are we training the scientist to ask the right questions?
When we think about that very thing of science and asking the right questions, and really the purification of the type of data that we're training these models with, if you will.
Yeah.
I think about, Ippolito, the abstraction of what we don't understand of science, and the capability to be able to take a part of science and apply it to become a product, only to turn around and use that product that originally comes from science, if you will, to go back and to unlock and understand more of what we don't understand about science, using science democratized to understand that which we don't understand when it comes to science. Is that relevant?
Definitely relevant. I mean, we have a classic dogma, if you will, in science. It's the design, build, test, learn cycle, right? So in each one of these stages, in the design phase, we are thinking about the experiment. We're thinking about our hypothesis. This is the question, if you will, and what I was talking about. But then we have the build. This is the manufacturing. These are the actual tools. This is the actual boots on the ground. And then we have to learn from this, and we have to test it. So all of these cycles, the cycle that has actually been established for years and years, is actually at a precipice right now in changing the way in which we actually go through this cycle. So what can we learn from a simple question is now becoming a lot more layered, right? So I can ask, okay, what does this molecule do to this molecule in the tube? So what's happening in the tube, right? That's very simply put. But now what we're able to do with immersive spaces in the laboratory is, how can one operator, maybe someone in the lab performing a set of tasks, change the process or change the actual outcome when compared to another operator. So now it becomes turned into a very human-centric focus, where we can actually pull apart and gain valuable insight to the variabilities that are happen within the lab. And on top of that, there is a certain level of trust that needs to be built, right? What is happening in the lab? If we can simplify it for people that have no idea, many people think that the COVID-19 vaccines historically, historically approved, brought out to market in record time, right? People don't realize that there was years, a decade of early development or early stage research that went into the delivery of those platforms. And so when it comes to public trust, when it comes to transparency in the lab, when it comes to trusting the actual scientific process in the lab, I think these immersive spaces and being able to share those immersive spaces can actually give us a lot of insight into what's happening in the realm of science and how science is feeding back to our society.
And as we look at science, and well met and well expressed, Ippolito, as we look at science and we think about the considerations of laboratory reproducibility and discovery, we must ask, to what advantage does this offer humanity for human betterment?
Hmm. Well, we talk a lot about democratization. Um, I asked the question earlier, how do we train up a scientist? Well, who wants to be a scientist? Let's channel back into the last panel. How are we actually priming or inviting our youth to be a part of even that field, right? So right now, you could say, for example, a use case is that, I think about years ago when I was in at UC Santa Cruz. It would take, so the amount of time that it would take to finish a quarter of the university. Within that time, the technological advancements would happen so quickly that by the time you were finished learning a course, the technology within that space had already developed and already had advanced faster than we could even learn about. So how, in this rapid, fast-paced movement of technology that's advancing faster than we can even ask a question, how do we invite the youth? How do we invite the next generation of scientists? How do we engage and funify, as my good friend Lubna has quoted, gamifying the lab, making it exciting, making it fun? That actually will change the way in which science is done, therefore changing the effects and actually the outcomes of what's produced in the lab. We think a lot about representation, and so that's important. Representation in the lab, in the sciences. We need more STEM for the next generation, and we need to prime that and really engage the youth with that cause.
When we think about biological warfare, chemical warfare, we think about the atrocities that are done with present day technologies. But when we also think about simply the natural development of diseases, and we think about so many of the diseases that are so forthcoming and so prevalent and so present right now in today's modern society beyond COVID-19, and thinking about polio and so many other different diseases that are known and certainly that are derived that are unknown.
Yeah.
It seems to me with this type of gadgetry that we have available in these products,
Right,
that isn't it just so important when it comes to the study of life sciences and biosynthetics and thinking about bio DNA and synthetic DNA, and we start looking at this whole construct and this whole ecosystem of the type of applied science of things. We've never been this way before, closer to physics than we've ever been in the modern era of AI. How important is this relationship now that we know that we can see with computer vision, that we can see more expressly in extended environments? For why have you gone this trajectory in this way in your work?
Hmm. Well, I was talking about the data sets that AI has offered us. Um, the data sets that we feed into our AI models um, are it's what we get back, right? And there's a few articles about how artificial intelligence failed us during the COVID pandemic, and there's polarizing views on this. Why it's so important to consider the intersection of these three things of computer vision, spatial mapping, artificial intelligence, and science is there has never been a more important time in history for us to leverage everything that we can to equip the scientists, to equip the front line. There are huge institutions, pillars, if you will, since the beginning of what we can understand as the modern world. There's the pillar of science that has informed the big pillar of medicine. At the cross section of these pillars is technology, and at the core of of artificial intelligence and the emerging technologies like spatial computing, at the core there is a purpose, and the purpose, as many on the at the summit have really drawn into and really pressed into, is humanity. At the core, we have to understand the needs that fuel the development, that fuel the importance of this. And so I would say it's a matter of prioritizing. It's a matter of prioritizing the use case for laboratory usage. It's about prioritizing and getting ready for all of the pandemics that we're getting ready to face, all of the ups and downs, all of the global challenges that we face. There are solutions if we can actually preserve that the mindset of asking questions, if we can preserve that plasticity of thought and not be bogged down with years and years of linear thinking. As our colleagues were saying yesterday in day one, that single-minded one-track system. I'm going to be an engineer. I go from one place to the other. It's a straight line. If we can get ourselves out of that linearity and understand the phylogeny and the branch points of discovery, we realize that the relationship between the science and the scientist and the technologist is actually critical for our future. The relationships are critical, Chris.
Indeed, Ippolito. And in closing, might we add just a lend of just a few more words here with the closing minute that we have, that on the macrocosm, we see the universe, and on a microcosm, the human body. Taking advantage of this critical relationship when it comes to the scientist, the frontline worker, if you will,
Right.
the technologist, and understanding more about the universe, but more so about these vessels, these bodies that we have, and to be able to better understand that, especially at a time of eco-convergence where we're seeing these technologies paired together and through technological transfer. Now we're starting to see the technological convergence of things that you won't even find in the novels of fiction.
Exactly. We're reaching beyond what we could even dream of. Are we ready to take that journey and to discover?
Amani, Ippolito, my dear friend, I'm so thankful to be able to share this stage with you.
Likewise.
GatherVerse, this is Ippolito Caradonna, a molecular biologist, a technologist, a leader, and a dear friend. I hope that you embrace him as we embrace you, as you embrace me. Our gather was well.
Thank you. Take care.
Prepare for our next roundtable and our final one of this very short and very fast day 2 audience. We need to better understand the world of content, because with platforms like Sora that's been deployed and other different types of stable diffusion models and content itself, we need to hear from our leaders. We need to hear this discussion. I'll be dialing in too. Our gather was well, may our gather be well.